All right, Unit 5, Lesson 3, Investigation 1, Common Logarithms. All right, to get started, we calculated these 10 squareds, 10 raised to different powers. What's 10 to the second?
100.
Good, 100. 10 to the third?
1,000.
1,000, nice. 10 to the fourth? 10,000. 10 to the first? 10. 10 to the 0? 1. 10 to the negative 1?
0.1.
What's it?
0.1.
0.1. 10 to the negative 2?
0.01.
0.01. 10 to the negative 3?
0.001.
0.001. Okay. The two that I think students are the most surprised by is 10 to the first being 10 and 10 to the 0 being 1. Okay. This one, just kind of a side note, anything to the 0 power is 1. Okay. Any number, decimal, negative, anything you want, raised to the 0 power, you get 1. Okay. Kind of a cool thing. All right. Now, looking at these numbers, are there any patterns that you guys see? Yeah, what's pattern, Matt? Good. The exponent tells us how many zeros we have, right? Exponent of 2, 2 zeros. Exponent of 3, 3 zeros. 4, 4 zeros. 1, 1 zero. Right, does that make sense? Yeah? Exponent of 0, how many zeros? None, no zeros. Okay. What about the negatives? Does the zeros thing work too?
No, it goes slide over.
Okay. Okay, it's how far into the decimal point, right? Or you can think about it this way. The exponents tell us how many decimal points and zeros there are. Okay? Always starting with what? A decimal point, right? So negative 1, 1 decimal point, right? Negative 2, 1, 2, right? 1 decimal point, 1, 0, still that's a 2, right? Negative 3, 1, 2, 3. So kind of still the same pattern going on. It's just with negatives, you need to include decimal point as well as your zeros. Does that make sense, guys? Okay. Now we can raise other numbers to powers, and like you saw on the video, log works with other numbers besides just 10. But for this class, we're only going to work with 10. Okay. We're not going to do log base 2 or 3. We're only doing log base 10. Okay. And remember in the video it says if we just write log, and we don't have a base, what do you assume it is? 10. If it just log is right with no base, that means 10. So on your calculator where it just says log, that means log base 10. And we'll get more what that means in a little bit here. All right. Now, one thing that you might be wondering how to do. How do I solve for x in this situation? Okay, 10 to the x equals 345. Does anybody know? How do I solve for x in that situation? Divide? Yeah? Well, if I'm dividing, that means something's being multiplied by x. Is anything being multiplied by x? No. Square root only works for powers of what? 2. Should I add? Subtract? Multiply?
No.
No! We have to bring the exponent down, don't we? Okay. Now, most important part of the video. Log of a equals b. Why? Why is log of a equal to b? Where's my mouse? Okay. Log base a of b equals c because, and I'll turn the sound off. Because, wait for it, a to the c equals b. All right? Log base a of b equals c because a to the c equals b. Okay? That's the most important part. Okay? So, looking back over at our 10x to 345, a is my base, right? Right? 345 is my b. C is my exponent's my answer, right? So what log does is it tells us what we need to raise 10 to in order to get that number, right? It's figuring out what power I need to raise 10 to in order to get 345. That's kind of handy, isn't it? I think it's kind of handy. All right, so try it out. In your calculator, they just have log because log base 10 is the one that we assume we have. All right. So if there's no base, if there's no number written, that's log base 10. So log like this and log like this mean the same thing. Okay? So you guys can calculate it. The log button is right next to the 7, just to the left of the 7. You type log 345, close your parenthesis, and you can calculate your first log. No bark or wood chips involved. What is it? So Davion says 2.5. A little further, please.
3,
7, 8, 1, 9, 8,
Okay, 819.
Yeah.
8, 1, 9.
Okay, we'll go 2
9, 5.
Okay, we'll round it up. Thank you. Nice job, guys. So this is telling you that if I do 10 to this power, what am I going to get? 345. We'll try that out. Do 10 to 2.53782, bless you, and see what you get.
Do what?
Do 10 to the 2.53782. Let's see what we get. 340 what? Okay, so 345.0007 something, right? Right, close to 345, isn't it? Why do we have all these extra zeros added on? What did I do? We rounded up, right? If we round down, then it'll be 344 point something.
99277.
Okay. Kind of cool, don't you think?
Sure.
I think it's cool.
It's alright.
So, one more time, what log does is it figures out what number we have to raise 10 to in order to get the number we're taking the log of. So if I'm doing the log of 345, it's figuring out what power I raised 10 to get 345. So log is kind of like the opposite of powers. Log is kind of like the opposite of 10 to the x. Kind of like how addition and subtraction are opposites, logs and 10 to the x's are opposites. Does that make sense? Any questions? Any questions? All right, so logarithms. A logarithm, and I did spell it correctly, I had to look it up on my computer. All right, a logarithm is an operation used to determine the power a number, or in our case 10, must be raised to obtain a new number. Okay, I put 10 in parentheses because all we're going to work with in this class is 10. Okay, we're only going to do log of 10, or log base 10. So an operation used to determine the power a number, or 10, must be raised to obtain a new number. That song stuck in my head.
Mine too.
Log base A of B is C. A to the C equals B. Have fun.
I don't know.
You get a lot of people.
Friends, you really have no life.
Sit at home just looking up these boring videos.
He's watching Big Bang Theory.
I do watch Big Bang Theory a lot.
This was fun. You guys.
I do have all 4 seasons for a reason.
You do?
Once football season's over, I just sit down on Saturday mornings and watch Big Bang Theory for sure. All right, Star Wars Clone Wars then Big Bang Theory. All right, so log A of B equals C. What does this mean? Because A to the power of C equals B. Wonderful video. Log base A of B is C because A to the power of C equals B. Not quite as catchy as the quadratic song, but it still works. Okay? So what this tells us, what the log is figuring out, log determines or finds what power we raise A to get B. Right? And that power is what? C. All right. So log determines what power we raise A to get B. All right. That's how logs work. That's how logs work. And that's why that video is so helpful, despite all the interesting pictures. That's okay. Better than me. I'm better than that though. No, I shouldn't say that. That's more musical than me.
So cheesy.
All right. It does. So log of 100. Okay, log of 100. This is figuring out which power we need to raise 10 to get 100, right? This is figuring out what power we raise 10 to get 100. Does anybody know what power we raise 10 to get 100? 2. Look at that. You can do it without a calculator. Kind of cool, huh? We did. So what we did over here with 10 to the second, 10 to the third, 10 to the fourth, that ties into these logs right here. Because that's how log and 10 to the power work. They kind of work back and forth. All right. Log of 100 figures out what power we raise 10 to get 100. Log of 1,000, what power we raise 10 to get 1,000. What is that? 3. Isn't this fun?
No.
Oh, man. All right. So I want you to fill out the rest of these on your own. All right. Do not shout them out. Okay. Do not shout them out. I want you to take some notes and fill them in on your own. One thing you might want to add to your notes is the fact that 10 squared equals 100. And 10 to the third equals 1,000. Okay. So try those on your own. Maybe add the little part about 10 to the power equals something. All right. I think those are always good to add. It's kind of like showing your work. The 40 pajamas are my feet so too much, so I got the footage off them. Eat my Cocoa Puffs and I watch Clone Wars and I hang out. Star Wars, you know what I mean? Same.
Nah, I ain't gonna lie, I do be watching.
Come party with me one time, Brad.
What?
Come party with me one time.
You watch Clone Wars?
Yeah, sure. Sure. You like to be great. You know, you watch.
Jay, you got those figured out? All right. Log of 10,000, what does this equal?
4.
4. Why?
Because
4.
Good. 10 to the fourth equals 10,000. Log of 10 equals 1. Why? 10. Good. I'm gonna put a little star next to this one. Okay, you'll know why in a second. Log of 1 equals 0. Because 10 to the
0
equals 1. Good. Log of 0.1 equals -1, because 10 to the -1 equals 0.1. Log of 0.01 equals 10 to the -2 equals 0.01. And log of 0.001 equals -3. 10 to the -3 equals 0.001. Honestly, how many of you did that without a calculator? Nice job, guys. Use the calculator, that's okay too. All right, now I put a little star next to this one, and I should have also started that one. The reason why I started this one, log base 10 of 1, you will use that a lot in the coming days. All right, when we start solving problems like this, or ones that are more complicated than this, then you'll be taking the log of 10 a lot. Okay? All right, be using the power principle of logs, the power principle of logarithms to solve these problems. All right, but you'll be doing log of 10 a lot. Anytime you see log of 10, what does it equal? 1. Okay. Anytime you see log of 10, it equals 1. Okay. Log of 1 equals 0. That's just reminding us that anything to the 0 power equals 1. All right. Never 0. All right. Any questions about how we did this? Any questions? All right. Now, time to throw you a little curveball. Somebody thinking, oh, curveballs are easy to hit. Others thinking, oh, I don't like curveballs. Little curveball. Log of 75. Davion, is that in our little chart we made at the beginning of class?
No.
Log of 75 is not, right? Log of 75 is not in our little chart. Do you think this will be a whole number?
No.
No, it's not going to be a whole number. Okay? It's going to be somewhere between 1 and 2. Okay? Because 10 to the first is 10, 10 to the second is 100, and 75 is between 10 and 100. Okay? How do I figure that out? What do you guys think?
Put
Log
log
it.
75 on
Perfect. Log 75 on your calculator. So type log. This number next. It's about next to the 7.
1.87506.
What is that?
1.87506.
Okay, we'll go there. 1.87506. Okay, you find the log? Okay. So log of 75 equals 1.87506. That is a funny looking 7. Okay, thank you. What does that mean? I call it memorable, not funny looking. All right. So what does that mean?
C and that.
Okay, that means C is 1.87506. That means my power that I'm raising 10 to is that, right? So this means that 10 to the 1.87506 power equals, what is it?
75.
75, perfect. 10 to that power equals 75. Does that make sense, guys? Yeah? I want you to try the next two on your own then. Fill in the which means too. Do the second part. Which means what? Okay. So log of 75, log of 750, log of 0.75. I want you to try those out and fill in that part where it says which means. All right, log of 750, what's that? 2.87506. What does that mean? Good. So 10 to that power equals 750. Or this one, log of 0.75.
-0.12493.
8? Okay. So we'll do 4. Okay. So what does that mean?
It's 10 to the -0.12494
Equals?
equals 0.75.
Good. Does that make sense, guys? Yeah. So it seemed kind of intimidating at first, but once we kind of see what logs are doing, it's really rather simple. Any questions on how we got those three? I got by the curveball. All right, so let's try the slider now. Log of x equals 4. Kind of a baseball move. They started preseason baseball this weekend.
Have you seen Moneyball?
No, I want to see it though.
It's really good.
It's really whack.
All right, before we get too far off topic. Log of x equals 4, log of x equals -6. Now, how is this different? Up here, we were calculating the exponent, weren't we?
Yeah.
Right? They gave me 75. So here, what do they give us?
Yeah.
They give us b, right? They give us the exponent, don't they? Or sorry, they don't give us b. They give us c. Okay? They give us c from our log of a equals log base a of b equals c, right? They give us our c, don't they? Right? Remember, log base a of b is c because b or a to the power of c equals b, right? So here they give me my c, my b is x, right? Log base a, which is 10, of b, x, equals c, because a to the power, oops, not a, our base here is 10, because a to the power of c equals b, okay? 10 to the 4th equals x. So, what's 10 to the 4th? 10,000. Right? 10,000 equals x. And how do you suppose you can check yourself? Calculator, right? You can do log of 10,000 to make sure it equals 4. You can try it out if you want to. But I think you already did it over a little bit earlier. Okay. So there's two more I want you to try. So I want you to try -6, log of x equals -6, and log of x equals 2.3. All right? And just remember, log base a of b equals c because a to the power of c equals b. They're written over there too. It's the same thing. So the things I have written right here are also written right here. So this was 10 to the 4 equals x.
Oh, God bless you.
Here, what's the question?
How do you put a negative?
Just the same thing. It's just we have a negative exponent.
It doesn't work.
Yes, it does.
Yeah, this is one E.
Should it be like this?
Right, 10 to the negative 6.
Should it be that?
Yep, that's fine. Or decimals 1, 5 zeros, and a 1. No, you don't do log of it. Because what that's saying up there is log of x equals negative 6. What that's saying is that the exponent is negative 6. Yep.
What? I just read 1E.
Yep, or point, decimal points 1 and then 5 zeros.
That's 5 zeros when it's an E?
No, the negative 6 tells you it's 5 zeros.
Oh.
We have in the head.
Oh, shit.
So that means that, so this right here meant that 10 to the 4th equals our x, right? So this means that 10 to
Why is he staring?
negative 6 equals our x.
Okay. Why are you staring at me?
Guys, take it easy. All right, so log
What is that? 1, 2, 3?
2.3. 2.3. 2.3. Yep, it's these two. All right, so in this one, what's my exponent? Negative 6, right? So log of x equals negative 6. That means that 10 to the negative 6 equals x. Okay. Now in your calculator, they have 1e negative 6, right? Remember from science class, that's scientific notation. 1 times 10 to the negative 6, right? Or we can use that little rule we said earlier. The decimal is 1. Then how many zeros do I need? 5, because they're gonna add, because the 1 decimal and the 5 zeros add to 6. So this is 0.1, 2, 3, 4, 5, 1. Like that. Log of x equals 2.3. What's my exponent? What's my exponent?
1.99. 199.
Oh, a little ahead of me, David. What's my exponent?
Oh.
2.3. So it's 10 to the, good, 10 to the 2.3 equals x. What's 10 to the 2.3, Jakai? Okay, so 5, 2, 5, 3. Does that sound good?
No, it's not.
No?
Oh, yeah, it is. My bad.
Okay, because 5, 2, 6? All right. All right, any questions? Any questions? No one?